welcome back. Let's continue with the topic carbonyl compound. Now we are in the 9.3, prepare the carbonyl compound. Basically, we already go through this process in the previous chapter. So ozonolysis of alkene will able to produce carbonyl compound. Okay, so generally is break the double bond and add oxygen next to the double bond. Okay. Second, Frederkraft Oscillation to produce aromatic ketone. This one we learned in the chapter of benzene. And then oxidation of alcohol. Basically, we know primary alcohol, if react with weak oxidizing agent, will produce aldehyde. And then secondary alcohol react with no matter strong or weak oxidizing agent going to produce ketone. Okay, now let's proceed to the tutorial question number 4. The structure A, we can see there are two functional groups. One is Cl, halogen, and then another one is OH. Okay, so to get this structure, maybe we have to identify first. This alcohol is primary, secondary, or tertiary. Because when we see K2Cr2O7, we know this one is oxidizing agent. So CH, CH3, CH3, continue with CH, Cl, and then CH, CH3, OH. So basically, we know that this haloalkane is secondary. This alcohol also classified as secondary. Due to the secondary alcohol, when undergo oxidation, will produce ketone. So we focus on the functional group. So what will happen? We will remove the hydrogen, and then here will become remove the H and OH, and then basically we are going to form double bond O. So if I change this CH3 to another side, so you will be able to see, yes, this is the structure of ketone. Okay, then now we proceed to question B. When we see O3 with the functional group carbon-carbon double bond, so we know this is the ozonolysis. Do keep in mind that ozonolysis will make the alkene have lesser number of carbon. So for example, in this case, the double bond will be break down, so we will produce two structures. Structure B is CH3, C double bond H. And then another structure will be CH double bond, and then continue here is CH2, CH3, CH, CH3, 2. So like just now we say, if we make the ozonolysis, break the double bond and make it to two structure, then we just add the oxygen next to the double bond. So we can see here we have the hydrogen, so both B and C are aldehyde. Last one basically is the Frederkraft Oscillation, because we can see there is a benzene. Okay, so from here we know that this part of the structure is from the benzene, okay, which is similar with this one. Then we know the structure D will have the CH3 attached to the benzene ring, and then suppose they have C double bond O, and then we have to add on Cl, because we know this is Frederkraft Oscillation. So means that it will react with acyl chloride. Okay, so we already done for the question, which is very direct with the preparation of carbonyl compound. Okay, after knowing how to prepare the carbonyl compound, so now we proceed with the chemical properties of carbonyl compound. Generally, the carbonyl compound can undergo nucleophilic addition, reduction, condensation, oxidation, and also iodoform test. Okay, so now let's identify a few reaction over here. As we know, iodoform test in chapter alcohol, at where we're going to detect the methyl carbonyl, will show positive result towards iodoform test. So in this chapter carbonyl, only methyl carbonyl will give positive results towards iodoform test. From the name methyl carbonyl, so we know the compound supposedly have a methyl group, and then this methyl group will attach to the carbonyl, C double bond O, and then another bond can be any structure. Okay, so the iodoform test, basically we will see the reagent is iodine in NaOH. So second, next we are going to look at the oxidation. So with CmNO4, so basically aldehyde can be oxidized, but ketone cannot be oxidized because there is no hydrogen at the ketone. Okay, condensation. What's the meaning of condensation over here? So condensation is basically we are going to combining two molecules and eliminate a small molecule such as water. So what are the reagents? Basically, for example, hydroxylamine, hydrazine, phenylhydrazine, 2,4-dinitrophenylhydrazine, which also as the identification test for the carbonyl compound. So this identification test will be known as Brady test. Okay, we will discuss Brady test further later. So the second last equation is the reduction. So reduction basically is the opposite side of oxidation. So the common reducing agent is lithium aluminum hydride, most common. Sodium boron hydride in methanol basically will be used in chapter carbonyl, while hydrogen in catalyst been seen in chapter alkene as well. The last one, which is nucleophilic addition, which is quite specific for carbonyl compound, where we can see such reagent, KCN, NaCN, water, alcohol, sodium bisulfite, Grignard reagent. So basically, we already learned Grignard reagent in chapter alcohol. Haloalkane. Grignard reagent react with carbonyl compound to produce alcohol. Now let's proceed to the tutorial question number 3. Draw the structural formula of the product form when 3,3-dimethyl butana react with sodium boron hydride in methanol. Like just now we mentioned, once we see this reagent, we know the reaction happen is reduction. So when we go through the structure B until H, C also are the reducing agent. So both these are reducing agent. So when the 3,3-dimethyl butana react with both reducing agent, they will produce same product. Okay, so as we know, primary alcohol when undergo oxidation will produce aldehyde. So when aldehyde undergo opposite side, which is the reduction, so basically it will form back the primary alcohol. Similar case happen to the secondary alcohol. If undergo oxidation, will produce ketone. So let's say later in the question, you have ketone and the ketone can undergo reduction to produce secondary alcohol. So now we start with 3,3-dimethyl-butana. So 1, 2, 3, 4. So the aldehyde group will be at the terminal. So 3, 3, CH3 will be here, CH3 also will be here, and then this one also CH3, so this one is CH2. So from this structure here, we can see that this is the aldehyde. So the alkyl group will remain the same. CH3, 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 CH2. So this C double bond OH will turn to primary alcohol. So we know that there will be one carbon attached to OH, and then this OH already attached to one carbon, but still have another 2 bonds. So basically these 2 bonds have to bond to hydrogen, so that the product form is a primary alcohol. Okay, still continue with tutorial question number 3. So after we identify the reducing agent and the aldehyde undergo reduction, then next we can see hot acidified CaMnO4. So we know this reagent refer to oxidation. So do keep in mind that aldehyde can undergo oxidation. However, ketone will not undergo oxidation because at the C double bond O, both right hand and left hand side of the carbonyl group is attached to the alkyl group, does not has the hydrogen. But aldehyde is R C double bond OH. So there is hydrogen over here, so able to undergo oxidation. Okay, so if aldehyde undergo oxidation, the aldehyde will produce or turn to carboxylic acid. So we write again, ketone, oxidation, no reaction. Okay, so now 3,3-dimethyl-butana. Draw again the structure. C double bond OH at the terminal. CH3, CH3 at the third carbon from the light. So this one will be CH2. So as usual, this is the functional group for the aldehyde. So means that the structure, except from the aldehyde part, it will maintain the same. CH3, 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 CH2. So the functional group C double bond OH will change to C double bond O OH, because the functional group for carboxylic acid is the carboxyl group, which is the structure C double bond O OH. Okay, as we know that carbonyl compound can undergo 5 reactions. The one is reduction, which we already discussed. Second, oxidation, we also already discussed. So now we are going to enter to the third one, which is the condensation. So if we look at tutorial question number 3, the reaction F is the condensation. Similar case to the tutorial question number 4D. Okay, so I will use 2 examples to explain the condensation. Okay, so CH3 and H2 react with 3,3-dimethyl-butana. So we draw the structure of butana first. C double bond OH, CH3, 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 here is CH2. Okay, so before this, we already mentioned that condensation basically is combine 2 molecules by eliminate one small molecule. So what will we eliminate? For the carbonyl compound, they will always eliminate the oxygen. And then for the hydrazine or amine, they will going to eliminate the H2 from the nitrogen and become H2O. Okay, so this is how the structure will be formed. So like before this we mentioned, CH3, CH3, CH3. This part will maintain the same. The C double bond O, I maybe will change to right hand side, and then the H at the top here. That means I just change the position of the double bond at the hydrogen. But actually they are still attached to the same carbon. Then for this amine, we taken out the hydrogen. So means that the part that attached to the carbon double bond will be nitrogen, and then this nitrogen will bonded to CH3. So even though the hydrogen already eliminate 2 hydrogen, but they still have 3 bonds. So the small molecule, basically we know H2 and O combined will produce H2O. Okay, question 4D, this one is 2,4-dinitro. Di is D, dinitro, and nitro, we have 2 nitro at the position 2 and 4. Phenyl is P, which consists of the benzene ring, hydrazine. So the hydrazine is the parent. So this part is the parent. When 2 nitrogen together, basically it is hydrazine. Okay, so after we know the naming for 2,4-dinitro, phenylhydrazine, so like usual, refer to the question number 3, we say that for the ketone, we are going to take out the oxygen. And for the hydrazine or the amine group, we will take out 2 hydrogen. So now in this case, how we are going to draw the structure? So like usual, if I am the one, I always prefer to start from the ketone structure, LD carbonyl structure, so which is CH3, and then the position of the double bond I will change with the methyl group. CH3 and then double bond. So and then I will connect with this structure, which is the nitrogen, and then connected to nitrogen, H, the hydrazine, follow with the phenyl, and then 2,4. Okay, so we can follow here. Okay, NO2. So 4 is the opposite side, so it's NO2. So this one I'm going to erase. So this is the product. And if the question is asked us to write the equation, don't forget the side product, which also is the H2O. Okay, now let's proceed to tutorial question 6A1, which is also related with the condensation, because they say that these 3 compounds going to react with the hydrazine. So the formula for hydrazine is NH2, NH2. Okay, so we start with structure A, which we have a benzene ring attached to CH2, CH2, CHO means is C double bond O, H. Okay, then we take out with the hydrazine, H2N, and then NH2. Okay, so like I mentioned always, I normally will change the position, double bond O with the single bond hydrogen. So here going to check with here. So this one will be hydrogen and then double bond O also. Okay, so as usual, we know that the carbonyl compound will take out the O, and then the hydrazine will take out the H2. So end up we will have this structure, benzene ring attached to CH2, CH2, C double bond H, and then going to connected with nitrogen, and then NH2. So this one is for the A. So now we proceed to the B. So same case, we also have a benzene ring, and then we have CH2, C, I will change the double bond, O with the CH3 like this, and then same case, react with hydrazine. So the O and the hydrogen will be taken out, okay, will be eliminated, and then these are the product that going to form. Benzene ring connected to CH2, CH3 double bond, and then not related to nitrogen. So this is for B. So now let's continue with the C. So basically we just repeat the same thing. No matter how the structure looks like, you just change the position. C, so here I will make it become CH2, CH3, and then the double bond O at the right hand side, and then react with hydrazine. So O and from the double bond, and then H2 from the hydrazine. So end up I will get this structure. C, CH2, CH3 double bond, and then connect to N and NH2. Okay, so the question is asked us to write the equation. So don't forget, everyone here, please add on the H2O as the side product. Okay, so basically in this video we learned the chemical reaction that carry out by the carbonyl compound. In details is reduction, oxidation, and also condensation. So in the coming video, we will focus on the nucleophilic addition and also iodoform test. Thank you for your attention and see you in next video. Bye bye.